Hello everyone, this is Yaoyu from class EL6303. Now I will solve question 2 of homework 3 in this video. In this question, because we have already know that x is uniform ranging from a to b and y equals to x squared, then we can write the density function of x should be written like this. Fxx equals to 1 divided by b minus a if x is greater than a and less than b. Otherwise, it should be 0. Then, based on the density function of x, it's easy for us to find the distribution function of x by the formula that the integral from minus infinity to x f x alpha d alpha equals to when x is less than a, the distribution function equals to 0. If x is greater than a and less than b, the distribution function equals to 1 divided by b minus a times x minus a. Otherwise, the distribution function is 1. And we also know that y equals to x squared. Then x equals to positive and negative y square root. And given by the density function fyy equals to the density function of x fxx divided by the absolute value of derivative of gx at g inverse x, then we can easily figure out when y is ranging from a squared to b squared, the density function of fyy equals to the density function of fxx divided by the absolute value of a derivative g of x at x equals to y square root plus the same form at x equals to minus y square root. And the answer is 1 divided by 2 times b minus a times y square root. And now let's consider when y is ranging from 0 to a squared. The density function fyy equals to 1 divided by b minus a times y square root. And in other conditions, fyy equals to 0. For question B, we are given a equals to minus 1 and b equals to 3. In this case, the density function of fyy could be when y is ranging from 0 to 1, it equals to 1 over 4 times y square root. And if y is ranging from 1 to 9, the density function of fyy equals to 1 divided by 8 times y square root. Otherwise, the density function is 0. Now, given the distribution function formula of fyy equals to the integral from minus infinity to y, the density function of fy alpha d alpha equals to when y is ranging from 0 to 1, the distribution function equals to a half times y square root. And if y is a number between 1 and 9, the distribution function fyy equals to a quarter times y square root plus 1. Moreover, if y is greater than 9, the distribution function of fyy equals to 1. Otherwise, the distribution function is 0. After we found the distribution function of y, we need to thinking about the expectation of y. Actually, the expectation of y should be in the form like this. It should be the integral from minus infinity to positive infinity y times the density function of y dy. And now we can divide this formula into two parts. One is the integral from 0 to 1 y over a quarter times y square root dy plus the integral from 1 to 9 y divided by 8 times y square root dy. And the final answer of this question is 7/3.